Good morning, students. Chapter 6, Work Energy Power. In last lecture, we have discussed about what is work done by a variable force and what is kinetic energy, work energy theorem. Yes, today we will see work energy theorem again, but it is for work energy theorem for variable force in one dimension. For variable force in one dimension. See, for example, let object is moving in x direction, that is x-axis, x direction, due to variable force fx, okay. So yes, we have to prove what is work energy here. See, we know that equation of work for variable force, it is fx dx, and yes, here it is from x1 to x2. Yes or no? Yes. W is equal to fx dx. Now I can write this as x1 to x2. F means ma according to Newton's second law of motion. Yes, is equal to x1 to x2. A means dv upon dt, and that here it is dx, and that here it is dx. Okay, is equal to, it is integration x1 to x2 m. Now see here dv upon dt, and here it is dx, but I can also write this term as dx upon dt, and here it is d, and here it is d. Clear about this? Okay, so yes, now I can write this term as w is equal to integration x1 to x2, m dx upon dt means this v, and here it is d. See, here integration is with respect to x, so we have to put limit of x, that is x1 to x2. Integration with respect to x, so limit x1 to x2. Now here integration is with respect to v, that is velocity. So I will change this limit, that is from v1 to v2, where v1 is initial speed and v2 is final speed. Okay, so now what is changed? Again, w is equal to f dx, f is equal to ma, a is equal to dv upon dt. I can write this term as, okay, m v dv. Here integration is with respect to v, so I have to change the limit of v. Okay, now w is equal to m constant, so it is out of integration. Integration v1 to v2 v dv. Now you know that what is integration x dx? Yes, it is x squared by 2. So what is integration v dv? It is v squared by 2. So w is equal to, it is m. What is limit? What is integration of v? It is v squared by 2. Limit is from v1 to v2. Clear about this? Now put limit. W is equal to m. Now limit. How to put limit? Yes, limit means upper limit minus lower limit. So first of all, you have to replace this v by v2, that is v2 square by 2. Always negative sign between them. Then v is replaced by v1. So here it is v1 square by. Clear about this? Okay. Again, m constant means out of integration. v1 to v2 v dv. Integration of v with respect to dv is v square by 2. Now you have to put limit, upper limit minus lower limit. V is replaced by v2 minus v is replaced by v1. Okay, so yes, I can write this equation as w is equal to, it is, if I multiply this m inside, then it is half m v2 square minus half m v1 square. Okay, m is mass, v2 final speed, v1 initial speed. Yes or no? So yes, half mv square is nothing but kinetic energy. So I can say it is k2, and here it is k1. Where k2 is final kinetic energy. Okay, and k1 is initial kinetic energy. K1 is initial kinetic energy. So yes, we can say W is equal to delta K. W is equal to delta K. That is work energy theorem. That is work energy theorem. Clear? So yes, it is one easy and important topic. Work energy theorem for variable force in one dimension. Okay? Yes, you have to start from equation of work. A, its value, simplify, integration with respect to B, put limit. It is easy theory. It is easy theory. Clear about this? Okay? Now, yes, we know what is work done. Okay, by constant force. We know what is work done by variable force, and we also know kinetic energy and work energy theorem. So now we will see some questions based on this. Now we will see some questions based on this. See, you are given one question. A block is lying on rough horizontal surface, is displaced through a distance d by a force at an angle theta with horizontal. You have to find what is work done in this process. You have to find what is work done in this process. Okay, see how to find. Here it is. A block lying on rough horizontal surface. This rough horizontal surface means there is frictional force. This block is displaced by distance d. Okay, by applying a force F at angle theta with horizontal. At angle theta with horizontal. Okay, you have to find work done. You have to find work done. See, first of all, we have to identify numbers of forces acting. First of all, we have to identify numbers of forces acting on this block. Okay, obviously, always mg, it is acting in vertically downward direction. Okay, normal force will act in this upward direction. Yes or no? This force F is applied in this direction at angle theta, and due to that force, block is displaced in this direction. Block is displaced in this direction. So yes, as the surface is rough, there is frictional force in opposite direction. There is frictional force in opposite direction. Clear about these forces? Clear about these forces? Okay, again, as mass of object is m, mg is always acting in vertically downward direction. Normal force is always perpendicular to surface. Force is applied at angle theta, that is given. Okay, this force is given. Frictional force is in opposite direction of motion. You are only given this force. About these three forces, you have to think. You have to think. Okay. So now, out of these four forces, N and mg, they are in vertical plane. F in horizontal plane. But this external force F is not in horizontal or vertical plane. So obviously you have to resolve this F into components. You have to resolve this F into components. You have to resolve this F into component. One in this direction and one in this direction. As F is making angle theta with this component, it becomes F cos theta, and it becomes F sin theta. It becomes F sin theta. Clear about this? Okay. So yes, we have resolved this F into components. One F cos theta and one F sin theta. Okay. Now we have to find work. And what is equation of work? Work means component of force in direction of displacement into displacement. Yes, displacement is in this direction. So what is force acting in this direction? In this direction. Yes, at first sight you can say, yes sir, it is F cos theta only, but it is not only F cos theta. Frictional force is acting in opposite direction. So what is resultant force in direction of displacement? What is resultant force in direction of displacement, that you have to find. See, displacement is in this direction. Displacement is in this direction. Yes or no? Yes, in this plane, means in horizontal plane, two forces are acting. That is F cos theta and F. That is F cos theta and F. Yes or no? Yes it is. Yes or no? Yes it is. Then how to find this? See, here it is. Here it is. Force, resultant force, in direction displacement. In direction of displacement. Resultant force in direction of displacement. F dash is equal to, two forces are acting, F cos theta and F. They both are in opposite direction. As object is moving in this direction, obviously F cos theta is more, so it is F cos theta minus F. F cos theta minus F. So now first of all I will find what is value of F. We know that F is equal to, it is mu into N. We know that F is equal to, it is mu into N. Now again, how to find N? How to find N? See, this block is moving in horizontal plane. This block is moving in horizontal plane. It is not moving in vertical plane. It is not moving in vertical plane. So for vertical plane, I can write for vertical plane. For vertical plane, we know that sigma F is equal to 0 because object block is moving only in horizontal direction. Block is moving only in horizontal direction. Block is not moving, block have no acceleration in this vertical direction. So for vertical plane, sigma F is equal to 0, and it is possible when forces acting in upward direction is equal to N downward direction. So yes, N plus F sin theta is equal to mg. So N is equal to mg minus F sin theta. Mg minus F sin theta. Clear about this? So yes, put value of F is equal to mu. What is value of N? It is mg minus F sin theta. Okay? Okay? So yes, here resultant force in direction of displacement. What is resultant force in direction of displacement? F dash is equal to F cos theta minus, what is value of F? It is mu mg. Minus will become plus. It is mu F sin theta. It is mu F sin theta. So it is resultant force acting in direction of displacement. So therefore work W is equal to, it is F dash D. It is F dash D. Yes, remember definition. Force acting in direction of displacement into displacement. Clear? If surface is if surface is smooth, then there is no friction force. Then you can directly write F cos theta only. If surface is smooth, then no friction present, then you can write only F cos theta. So yes, your answer will be F dash is equal to only of F cos theta, it is F cos theta into D. But here, as friction is present, resultant force acting in direction of displacement is F cos theta minus F. So now you have to find value of F and put in this equation. So yes, work done W is equal to, it is F dash, this whole term, that is F cos theta minus mu mg plus mu F sin theta into D. It is equation of work done. Clear about this? Now next question, see, a body of mass 2 kg is at rest on a smooth horizontal surface when a force of 0.5 Newton acts on body. It is displaced in the direction of force. Find the work done by the force in 8 seconds. Show that this work is equal to change in kinetic energy of the body. Now see, we will write data. Here it is. A body of mass 2 kg. So M is equal to 2 kg. Is at rest. So initial speed is equal to 0. On a smooth horizontal surface, means no friction force. When a force of 0.5 Newton, F is equal to 0.5 Newton, acts on a body, it is displaced in the direction of force. So see, first of all, M is equal to 2 kg, F is equal to 0.5 Newton. From these two data, you have to find acceleration. That is acceleration. A is equal to force upon mass. Acceleration A is equal to force upon mass. What is force? It is 0.5. What is mass? It is 2. 0.5 divided by 2, it is obviously 0.25 meter per second. Clear about this? So yes, first of all, we have to find what is acceleration. Now, when a force of 0.5 Newton acts on body, it is displaced in the direction of force. In the direction of force. Displacement in direction of force. In direction of force. Okay, so yes, what is equation? How to find equation? Yes, we have to find equation like this. W is equal to F D cos theta. Now, as displacement is in direction of force, how to find F D? In direction means angle between them will be 0. Displacement is in direction of force, so angle between them is 0. So obviously it is F into D. Now see, you have value of F, that is here, it is 0.5 meter. But what is the displacement? What is the displacement? You have to find the work done by the force in 8 seconds. In 8 seconds. Yes, you are given value of F, but what about value of D? What about value of D? Yes, how to find value of D? So first of all, you have to find what is displacement in 8 seconds. So see how to find. Here we will find displacement in 8 seconds. Equation x, or we can write D is equal to, it is V0t plus half et square. So D is equal to, initial velocity is 0 plus half. What is value of A? 0.25. T, we have to find work during 8 seconds. So it is 8 square. Okay, 8 square, it is 64 divided by 2. 64 divided by 2, 32 into 0.25. So yes, D is equal to, if you find this, you will get your answer 8 meter. Clear about this? Okay, so yes, displacement in 8 seconds, it is 8 meter. Displacement in 8 seconds, it is 8 meter. Clear about this? Okay, so yes, it is 8 meter. So yes, now we have to put this value here. What is work done? Work done, W is equal to, it is F. What is value of F? It is 0.5 into, what is displacement? It is 8. So 8 into 0.5, it is 4 joule. Clear about this? So simple. But how to solve such questions? You have to find work done. So first of all, you have to write what is equation of work done, that is FD cos theta. Why we have used this equation? Because for 0.5 Newton it is constant. So W is equal to FD cos theta. It is FD cos 0. F is given. We are not given D. So first of all, we have to find D. And you can put this in this way. Okay. Another question. Show that this work is equal to change in kinetic energy of body. Change in kinetic energy means final kinetic energy up minus initial kinetic energy. Now, to find kinetic energy, final kinetic energy, we have to find what is speed at 8 seconds. Okay, speed in 8 seconds. So yes, we know equation. V is equal to, it is V0 plus 8. V is equal to, it is V0 plus 80. Okay, so V is equal to, initial velocity it is 0, A, it is 0.25, T, it is 8. So yes, V is equal to, it is 2 meter per second. Now, final kinetic energy means at time t is equal to A, that is AF. It is half m v square. It is half. What is value of m? This is 2. Okay, v square means here it is 2. It is 2 square. Clear? Speed at 8 seconds it is given. So this 2 square it is 4 joule. Okay, what is initial kinetic energy? Initial kinetic energy. Initial kinetic energy means at time t is equal to 0, and we know that ki half m initial speed is v0, and it is 0. So now it is final kinetic energy, it is initial kinetic energy. So kf minus ki is equal to, it is 4 minus 0. It is 4 minus 0, and it is equal to, it is 4, and see, is equal to, it is 1. Is equal to, it is 1. So yes, here show that this work is equal to change in kinetic energy of the body. It means with the help of this equation we can say the work energy theorem is obeyed. That is W is equal to delta K. Work is equal to change in kinetic energy. Clear about this? So first of all, to find work you have to find displacement in 8 seconds. Then to find change in kinetic energy, to find final kinetic energy, you have to find speed. Clear about this? Now next question and last for today's lecture. A particle moves from x is equal to 0 to x is equal to 10 meter on x-axis under the effect of force Fx is equal to 3x square minus 2x plus 7 I caret Newton. Calculate the work done. Calculate the work done. See here what is given. A particle moves from x is equal to 0 to x is equal to 10 meter on x-axis under the effect of force. Yes, we know that it is variable force. How we can say it is variable force? Fx is equal to 3x square minus 2x plus 7. As value of x changes, force also changes. Put x is equal to 0, put x is equal to 1, x is equal to 2, you will get different values of f. You will get different values of f. So yes, it is variable force. And we know that for variable force, what is equation of work done? For variable force, W is equal to, it is integration fx dx from x1 to x2. So it is integration fx means it is 3x square minus 2x plus 7 dx. Now what is limit? You have to find particle moves from 0 to 10. 0 to 10. So it is limit. X is equal to 0 to x is equal to 10. It is limit. So is equal to. Now how to integrate this? See, integration is with respect to x. How to integrate this? You know that. Okay. It is 3x cubed by 3 minus 2x square by 2 plus 7x. Limit is from 0 to 10. Okay, so is equal to 3 cut, 2 cut. So here it is x cubed minus x square plus 7x. Now you have to put limit, upper limit minus lower limit. What is upper limit? 10. Lower limit is 0. So first of all, you have to replace this x by 10. First of all, you have to replace this x by 10. That is upper limit. So 10 square minus 10 cube minus 10 square plus 7 into 10. Between there is always negative sign. And yes, as negative side, I will write second term in bracket. X cube means 0 cube minus 0 square plus 7 into 0. And we know that this term will become 0. So yes, you have to simplify this. 10 cube means it is 1000 minus 100 plus 7. Clear about this? Okay, so yes, what is your answer that you have to write? 1000 minus 100, 900 plus 7, it is 970. It is 970. It is your answer. Clear about this? Okay, so yes, it is one easy question that how to find work done for a variable force. Okay,